Hello everyone, today we will discuss that what is galvanic skin response sensor, which is also known as GSR sensor, and in this video we will discuss that how to build a GSR system using the operational amplifiers. To make a GSR system, first we have to know that what is a GSR sensor. The GSR is a psychological signal that measures the changes in the skin electrical conductivity. The conductivity of the skin varies due to the sweat glands activity that is controlled by autonomic nervous system. The GSR are widely used in stress monitoring, lie detection system, biofeedback therapy, and human computing interactions. So the question arises that why we need a GSR sensor. GSR sensor is a stress monitoring system, and many stress monitoring systems nowadays are quite complex and expensive. So we want to build a GSR sensor that is low cost, accurate, reliable, and stress monitoring system that can effectively minimize the signal interference. Our objective were to accurately mirror the changes in the skin resistance associated with the psychological stress. The second objective was to minimize the noise of the 50 Hz electrical interference to improve the accuracy and reliability of GSR signals. And the third objective was to evaluate the performance of the developed GSR sensor by testing its accuracy and stability. These are the list of the components we use to make our GSR sensor. For this, we use the operational amplifier, the transistor, diodes, and capacitor. These all are easily available at any market. We got these all from the Hard Road in Lahore, and these components were quite affordable and cheap. This was the picture of our circuit diagram that we used to make our GSR sensor. This circuit consists of the two transistor or BC547 transistor that are used for the signal conditioning network and the operational amplifier. The left electrode is connected to the base of the first transistor. The base is also connected to the positive 2V battery through the 100 kilo ohm resistor. The right electrode is connected to the node shared by the emitter of the second transistor. Second transistor, 4.7 kilo ohm emitter resistor and 1 nanofarad coupling capacitor. The collector of the second transistor is connected to the battery through a 4.7 kilo ohm resistor, while its base is connected to the collector of the first transistor through a 100 kilo ohm resistor. The 4.7 nanofarad capacitor is connected between the collector of the second transistor and the electrode node. The signal coming from the second transistor passes through the 1 nanofarad capacitor and then through the diode network, the 100 nanofarad capacitor and the 100 kilo ohm resistor filters, and finally through the 10 microfarad capacitor through the operational amplifier. The operational amplifier is based by the 47 kilo ohm resistor and 180 kilo ohm resistor, while the 2.2 mega ohm resistor provides a feedback between the output and the inverting input. The 1 kilo potentiometer with the 2.7 kilo resistor forms adjustable voltage divider connected between the plus 12 volts and the 0 volts. As you can see, we have done all the connections. We also made our circuit on the wearable board. Now, let me explain how does a GSR sensor works. First, the electrodes are placed on the hand to detect the small variation in the skin conductivity caused by sweat or emotional changes. And the second, the transistor stages increase the weak signals for the better processing. At filtering point, the capacitor and the diodes remove the unworking nodes to provide a stable and strong signal. Number 4 is the amplification process, in which the operational amplifier further enhances the signal and improves its accuracy and sensitivity. And number last is our output. The output voltage changes according to the skin moisture and stress level, making the circuit useful for the GSR measurement applications. We have mirrored our output wave on the oscilloscope in our labs. To measure our final output, we have connected our circuit to the oscilloscope and placed the electrodes on our hand. As you can see, at the normal condition, nothing is happening and our wave is at its baseline. As soon as the skin electrical conductivity changes, the wave goes from the baseline to higher, which technically explains that the upward movement of GSR signals from its baseline shows the increase in the skin conductivity. This occurs when the sweat glands activity increases, reducing the skin resistance. As a result of the skin sensor detects a higher conductance and the waveform rises. Thank you for watching and see you in the next video.